Okay, I know you're all very excited on this snow day to do a little math. But we got a little notes to talk about first, and there are 6 basic rules with integrals. We talked about them the other day, but I didn't give them to you, put down in notes. Right now is kind of the time I'm going to have you do that. And the integral rules are the following. I think they're pretty much straightforward when you look at them and understand what's going on. The first rule is called the positive and negative integrand rule, and it just says that if the integral from a to b of f of x dx is c, if you reverse the direction around, then the integral from b to a of f of x has to equal negative c. So if you knew for a fact that the integral from 2 to 5 of f of x equals 12, you then know that the integral of f of x from 5, starting at 5 ending at 2 equals negative 12. It's always going to be the opposite order. It's going to give you a negative answer. The reverse integrands rule is really the same thing as the positive and negative. It just says that if you have a function and you're integrating between a and b of f of x, and that's equal to negative the integral from b to a of f of x. You can just put a negative sign out in front, and we know that these two quantities will be equal to each other. It's the same thing as the one before, just not setting it equal to some value c, which then becomes negative c. The third rule is the sum of integrands being the different integrals you're adding together. And it's a pretty straightforward rule. If I have some interval starting at a and ending at c of f of x, that's the same as finding the first part of the integral, starting at a and going to b of f of x, and then starting at b and going to c of f of x, as long as a is before b is before c. And it's just what we talked about with Pac-Man eating things up. He could eat all at once. He can have one big meal and start at A and eat all the way till he gets to C. Or he can have a first meal, start at A and go to B, goes halfway there. And then he takes a break. Then after a while, he picks up again, starts at B and goes to C. The integrals he eats, the area he's going to eat is going to be exactly the same, as long as those numbers are in order. Okay, symmetric limits are special integrals, and there, when we have the picture, we can kind of see what's going on. There are 2 types of symmetric limits, meaning where everything's symmetrical around the y-axis. There's ones that are odd functions, where on one side the area is on top of the graph and the other side is on the bottom, or vice versa. And the other type is an even function, where the area on one side is exactly the same as the area on the other side, it's just mirrored across the thing. Well, the odd function is actually the nice and easiest. It just says that if you have symmetric limits, meaning start at one value like negative c and go as far as c, the area that little Pac-Man's eating, the negative area that he's eating, is going to be equal to the positive area that he's going to be eating, so everything ends up canceling each other out. So if you have an odd function, if you have symmetric limits, meaning the same number on top and bottom, just with different signs, the integral from negative a to a of f of x dx is going to be 0. That will happen whenever you have something that looks something like this. This graph right here, which is a horrible graph, would be considered symmetric, and it would be considered odd because here's a positive region, here's a negative region. They're the same size, so they cancel each other out as they're working. And on an even function, the opposite happens. They don't cancel each other out. You could just find the area on one half of the thing. If you have area from 0 to that to A, you would know that the area of the full thing is going to be twice as big. The area of the full thing is going to be twice as big.